Alright, folks, welcome back to another networking lab session. Today we'll be exploring a dynamic network topology with two multi-layer switches, three routers, and a layer 2 switch. Our focus will be on implementing EIGRP for dynamic routing, Ether channels for link aggregation, and VTP for VLAN management. Additionally, we'll be configure rapid spanning tree protocol for enhanced network stability. If you want to look at the diagram, we can see that the third router is connected to a layer 2 switch, and the router is getting a DHCP address from the router 2, and the address is being relayed through router 1 through the layer 3 switches and ultimately to the router 3. So let's start doing it on packet tracer now. I'm gonna put my router 1 here. Network diagram we have on the right side. I'm going to be using the same ports we have in this diagram to make things easier for us to understand and have a reference for. My gigabit 000 is connected to dynamic switch 1 G107. This is a routed port that we'll be configuring. And for our second multi-layer switch, we'll be making a trunk port which will be in VLAN 17, and it is connected to router 1's G011. Router 1 and router 2 are connected with G010 and G000. So this is another layer 3 switch that is essential for the working of a topology. We won't be configuring anything on here, but this is how we connect to the internet, and this is connected to router 1's G001. And lastly, we have a router 3 that will be a DHCP host, that will be acting as a DHCP host, and it will be getting an address from router 2. So let's connect it with our 11th port to gigabit 000. I'm gonna insert a PC here as well, which will also be getting a DHCP address. This will be my 12th port. Now, let's start with configuring the interface IP addresses first to make things easier for us as we move along. I already have written those settings in my notepad, so it will be easier for me to just copy and paste. So let's go into our R1. Firstly, let's configure the very basic host address setting. So this is my host name. I'm gonna put a banner for the access of my router 1. Now my interface G001. Switch on the port label settings here so that we can see the which port what. Now again, as I said, my G001 is getting a DHCP address. So one address DHCP and my interface. So I am another very essential thing. I'll be making 4, 5, 6, 7, 8 interface VLANs. Now in the diagram we have VLAN 100 as a data VLAN, but I'll be making my VLAN 10 as my data VLAN. So on R1, I'm gonna configure my data VLAN. We can use anything basically, but at the moment I'm more comfortable with using interface VLAN 10 and simultaneously interface VLAN 20 for voice VLAN and so on. So interface VLAN 10 settings, and the IP addresses is 10.10.255.254. To understand how my IPv version 4 address will be working is, as in the diagram we can see we have 10.60.255.254. So instead of using a VLAN, my reference number here will be, instead of using 60, will be 10. So this is my IPv version 4 address. And then my interface VLAN 17 will be 10.17.1, and the routed ports address will be 10.10.16.1 for G000. And this is how I will also be doing my IPv version 4 addressing. Unfortunately, multicast won't work on packet tracer, so I'll be doing a lab on GNS3 as well, where we can do it, where we can configure a multicast server on our GNS3 within the same topology, and we'll be able to do much more things. But this is on CCNP level. But if you want me to cover that, I'll be definitely covering that in my videos, in my coming videos. So now moving on to staying on track of our video, interface G010 will be a VLAN 10 port that up. Now interface 010 is up. Another will be, now I'm putting the IP address on my interface G011. It's a routed port, so just simply the IP address. For less confusion, I just want to make clear that G00 is this port and G011 is this port. I wish I could move them around, but staying on track. Now I'm interface G011. I'll be simply making interface VLAN 1. That will be an interface VLAN 1 port. You can choose anything. It does not matter. It does not for access interface. We have configured it now. Now moving on to other essential step. I want to configure SSH on my router 1 as well. And I want to configure a password on it as well. So I'm going to put on those settings. My console password will be Cisco. So yeah, my console password will be Cisco. I'm configuring a domain as with my name, and if I want to access it through SSH, the username will be admin. Again, password Cisco. I generated a crypto key for authenticity and encryption. I have an access list as well, which will enable me to only allow specific range of IP addresses. Now I configured the access class SSH, and this is my access list. So I'll be only allowing this range of IP address, which is 10.10.15.0. So 10.10.15.1 till 254. Alright, now let's move on to R2 and configure it. Again, basic settings. I'm gonna name it, give it my name. Interface G00, which is part of VLAN 10, will have this address. It will be routed port, so routed port is connected with port. It does not matter, it will work still the same, but I have to follow how this diagram is worked. This is how I'm in this exam. Now the basic settings, again I configured SSH in here, and this is my access list. Now as I said, R2 will also be acting as a DHCP server, but before I move on there, I would configure my switch 1, switch 2, that is my multi-layer switch 1 and multi-layer switch 2. I'll be back with configuring DHCP on there. First and foremost, I want to ensure that my switch 1 is my primary VTP switch. So for that, I will be running a VTP primary VLAN command in privileged configuration mode, but I can also do a do VTP primary VLAN. Here we are. Another essential thing, VTP version 3 does not work on packet traces, so VTP version 2, and the other commands work perfectly. Now my switch 2 will be a client VTP switch. So here we go, P domain, VTP version 2, VTP client, and then my switch 3. Alright, I've configured the VTP settings. Now let's see if the VTP is working. Alright, and for me to check this, I'm gonna configure some VLANs on here and see if the VLANs propagate. Alright, I configure VLAN 10 as data, VLAN 11 as voice, 12 server, 13 wireless, 14 guest, 15 net management, 111 plot, and 222 NAT. Alright, let's send this and see if VTP works. Show VTP status is a client, yeah. Show VTP, show VLAN brief. Oh, it hasn't propagated. It hasn't seen it. Alright, Udit, cut this. Udit, cut this. When I start again? Then, alright folks, let's start with configuring our multi-layer switches. So enable conf, my host will be hostname S1, and other basic settings same as what I've been configuring so far, and my IP access list the same. So I'm allowing the same range of IP address for SSH into two routers and my switches. Now on G107 I'm making a routed port, so for it to configure it as a routed port I have to run the command which is IP routing, and then I have to run another command which is the no switch port command, which is no SW here, and this is my IP address. So yep, the port is up now. Great. Now, my G1012 range is a LACP ether channel, which we can see in here. So my port channel 2 is a trunk ether channel configured with link aggregation protocol. All right, let's do that. The difference between PAGP, proprietary aggregation protocol, and link aggregation protocol is, sorry, cut this, start. So the difference between port aggregation protocol and link aggregation protocol is that the port aggregation protocol is a proprietary protocol, that is only Cisco switches use it, or it only works on the Cisco switches, whereas LAGP works on switches of other vendors as well. Now back to configuration. My G101 and G102 port is LACP, so I'm gonna give them the active mode. I'm making interface port channel 2 on there. My native VLAN will be VLAN 222, and I am also disabling the DTP settings, which is very essential to prevent rogue switches to get into our network. So interface port channel 2, they're in a trunking mode, my native VLAN, and the DTP is off. Now the range G103-4 will be my interface port channel 3, and they are routed ether channels, so they will be working as a layer 3 interface. They will be neither PAGP nor LACP. They will just be in the on mode, which is essential for layer 3 routing. Now my interface port channel 3 will have the following addresses. That is, oh, but wait, I didn't need to run the no switch port command because I already gave the no switch port command in the interface range command. Now the ports connecting two ports, G105 and G106, connected to switch 3 are in trunking mode as well. They are in LACP as well. So same command. They are in active mode, and I'm giving them port channel 4 just to not get confused when we start configuring our switch distribution layer switch 2. Again, they're native VLAN 222 and no negotiate. Now what to do of our switch ports that remain unconfigured? It is essential that we put them in the parking lot VLAN, which will be basically all of the unused ports. So my parking lot VLAN will be 111, and they'll be acting as access ports, but the thing is they will all be shut down and they cannot be used until I configure them in a certain way, which will be looking down. These ports are down now. These are in our access VLAN ports. Moving on to S2 now, as I said, we can see that we are getting an inconsistent port type, and the native VLAN by default is 1, but we have configured it as 222. So when we configure it here as 222 as well, we no longer will get this error. Now basic settings: host name, SSH command, the password command, and the banner. Done that. Access list, repeat the IP routing command for our routed ether channel to work. Interface G107. Now interface G107 has the address of 17.7, 10.10.17.7, and G101-2, as I said, is routed port. Here we go. And now to solve the blocking port channel 2 error, let's put our interface port channel 2 in the native VLAN 222, and our interface G103-4, since it is a layer 3 performing layer 3 routing, this port channel 3 and 3 mode on. Let's give it an IP address 67.7, same range as our switch 1's G103-4 as well, and our 5 and 6 port connecting to switch 3 are in channel group 4. I'm using again port channel 4. So same port channels on both sides, but the port channel number does not matter, and they are in same native VLAN as well, which is 222 DTP negotiators of rest of the switch port, the parking lot VLAN. Another essential step. Now, moving on to configuring VTP. So my VTP domain is Archet, VTP version 2. It is S1 is the server, so go. Device mode already in VTP server mode, and VTP primary VLAN, and VTP mode client already in client. Alright, so less of work for us then, yeah. Well, VTP domain, so same VTP domain, but it's also said, okay, I think I set it. I thought I didn't. Let's set it here as well. VTP version 2, Archet. Before I put the VLAN settings, it's essential that I configure switch 3 as well. So let's do the basic settings on switch 3 as well before we put on the VTP settings actually. So the same basic commands again, the access list, the SSH, the host name. Now 1 and interface fastness 1 and 2 are in LFCP, so let's do that. And now we are seeing the native VLAN error. Let's solve that. And my port channel 1, which is connected to port channel 4 in switch 1, port consistency restore. Amazing. Same thing for the another side, which is connected to switch 2. Let's do it again. To restore the port consistency. Yes, we're back. Rest of the ports, we will configure them as we want. We'll assign each port to different VLANs. But before we do that, we have configured VTP. So let's see if the VTP settings propagate. Currently, if we see show VLAN brief, you can see the VTP settings propagated. For switch 3 as well, show VTP settings propagated. Now, router 3. Basic settings. Again, at the moment we're not starting to configure EIGRP, but in a moment we'll be doing so. Before that, router 3, just simply we're gonna configure the host name, and my interface G00 is will be getting a DHCP address. That's it, yeah, and no shut. Before we configure those settings, let's try to understand what EIGRP actually is. Alright, so to get a grasp on EIGRP, so to dive into EIGRP, Enhanced Interior Gateway Routing Protocol, let's talk about its key features first. So EIGRP was developed by Cisco, and it is a great choice for routing within an autonomous system. It is a hybrid routing protocol which combines the best elements of both distance vector and link state routing protocols. So distance vector routing protocol like BGP and link state routing protocol like OSPF. Alright folks, let's configure EIGRP now. The routing protocol which is essential for the operation of this topology. Now EIGRP is a very massive protocol where to understand it basically we have to cover a lot of topic, but a basic overview of it will be is that within an autonomous system and within an enterprise network, it is a great choice, and we can use less of a commands for its basic operation. Now I'm gonna configure EIGRP on my switch 1 first. Pass with Cisco. So my only network is 10.0.0.0, which will uncover every single small network in my topology. For my router 2, it will only again be 10.0.0.0 global mode, and we have the router adjacency working. My switch 1 now. Switch 1 will also have only one command running for EIGRP in IP version 4, so the adjacency is up here again, and for switch 2 the same command. Now let's configure NAT and static routes for R1 to propagate traffic to the internet and R2 to ping internet as well. So the IP version 4 IP route command will be quad 0 through the interface going out, which is G001, and this is our IP route command. And now for the other ports to send traffic to the internet, we need to configure NAT. So the best option here is to configure port address translation. The first command will be, so I'll be using the following commands. I've already made the script for it, so I'll be explaining it when I run this. So my interface VLAN 10 connected to G010, IPNet inside. Interface VLAN 1 connected to G011, interface VLAN which is again inside, and interface G00 which is the routed port inside, and the only port that's outside is G001, IPNet outside. This is the range, access just one permit. I'm permitting this address to go out and propagate, and yeah, it should be working fine. So we will test this once I put the IP route command in my router 2 to see that if it works. And before we do that, go into my router 2 and configure DHCP here. Again, my DHCP commands are also very basic for the operation. I'm choosing an excluded address range. These are the addresses I'm configuring for these are the addresses I am excluding for the DHCP range to accommodate some static servers or static addresses to host, and the network is 10.10.10.0. My DNS server is 8888. Now let's see if I can ping to the internet. No, I can't ping. Oh, I can ping. Amazing. I can ping now. Amazing. Now I should also be able to ping 888 from 1, and I'm able to do so as well. 2. I have not got the DHCP address so far, and the reason for that is I've not configured the interface VLANs, and more specifically the interface DHCP relay. Now I'll start by doing so with my switches, configuring these on my switches. Configuring interface VLANs on my switches. So moving on to my switch commands. I have 5 interface VLAN with interface VLAN 10 acting as the one which will propagate the helper address or the DHCP relay messages through the helper address to switch 3 and simultaneously towards the destination. Now, since I already have the script for it, you can pause the video and make a note of it if you want to. So here we go, and yeah, this is my IP helper address with the following address. I'm changing only my third octet to represent the third interface VLAN 11, and simultaneously the other interface VLAN. I'll do the same for my switch too. So the AirDrop adjacency is also up, and the IP helper address is also configured. My 5 interface VLANs is also configured. I'll also be performing a hot standby routing protocol to load balance these interface VLANs to get a better understanding how an optimized and efficient network works and how these settings are really important when there are a lot of users. Now let's check if we got the DHCP address. 11 is striking. Now on switch 3, I want to put the unused ports on specific VLANs, and to do so I'm gonna be using these commands. Now my 11 and 12 are switch port 11 and 12 will be an interface VLAN 10, which is my data VLAN, and through my data VLAN I'm getting the DHCP address, and other fast Ethernet ports are in their own respective interface access, in their own access. Let's copy and yes, now we also have got the DHCP address from our DHCP server. 10.10.10.22 show DHCP show IP DHCP binding, and ping. I will also be able to ping the internet, my DNS server, that is 8.8.8.8. It will take a few moments, but as we can see, we got the result. Now all the basic connectivity is done. Now let's do some security configurations to optimize the network, and now also configure hot standby routing protocol. Let's start with configuring the hot standby routing protocol, which is essential. And to do so, I have the following commands: standby 10 IP address, preempt, and primary 105. So for S1 will be mostly carrying the traffic from VLAN 10, VLAN 11, VLAN 12, and it will be acting as the primary source for them. whereas switch 2 will be majorly carrying traffic from interface VLAN 13, VLAN 14 and VLAN 15. But for switch 1 we can see that I've put the priority as 96, and this will ensure that switch 2 carries that traffic. So let's put this configurations on our switch 1. Now simultaneously we'll put the hot standby routing protocol script or our configurations on our switch 2, and then now we can see that for here 13, 14 and 15 VLAN are at more priority than the 10, 11 and 12. Sorry. Now we have done a standby configuration. We'll check how the operation of this within a few seconds, but before this optimization, let's configure spanning tree, rapid mode spanning tree, which is also another very important aspect in our configuration and the whole operation as well. Now the command to run spanning mode in our switches is spanning mode. We'll be putting our 10, 11 and 12 in the primary, making them primary, where in primary root VLAN, and in spanning tree whereas 13, 14, 15, vice versa. Okay, cut this. For S1, 10, 11, 12 will be the primary VLANs, and for switch 2, 13, 14, 15 will be the primary VLAN spanning tree. So let's do that, paste it, and the opposite too. So by the time I feel like our show IP standby will also show standby, our standby VLANs have also become optimized, and we can see that in switch, what the fuck? And we can see that our optimization is complete. Amazing. Now lastly, we can also confirm our ether channels if they're working efficiently. Yes, they are working efficiently. Now let's do some security configurations which are essential for IP version 4. Let's configure IP DHCP snooping, and let's put our unused fast Ethernet ports on, unused and used in ports security configuration. So switch port security maximum 2, so maximum of 2 MAC addresses will be remembered by these ports. So if we try to continuously change devices, this port will be shut down due to a violation. MAC address sticky, it will remember the MAC address of the devices it was connected to, and thus giving the optimized and required security. Now another thing is we'll be getting DHCP messages on switch 3 from switch 1 and switch 2 DHCP packets, so to optimize that as well, we're putting snooping command on the interface that are connected to switch 1 and switch 2 and to the other ports as well. And to do so, I ran the IP DHCP snooping trust command. So interface 1 till 4 are trusted. We can get DHCP addresses on them. But on the other ports, we have put a limit that not more than 6 packets can be received for those. And interface VLAN 10 to 15 are the DHCP snooping mode. So these ports are also being monitored. That's right. Now for switch 1 and switch 2, our port security will basically be port fast that we have links on there, we have ports on there that are running ether channel and that are running spanning tree. So it's important that they have the port fast command. So basically what port fast command is doing is it is preventing the port from directly going through blocking and becoming active, or becoming listening, forwarding. So to prevent the blocking ports or disable ports to going in a forwarding state, we'll run this command on all of these switches that are running spanning tree. Here we go. And for IP version 4, our network is now optimized and working efficiently. To confirm once again, our router 3 has got the DHCP address, a switch and switch to have the auto running, and yes, be it.